Hey there, this is Jeremy Recorder, and this is my Physics 2212 Lab 1 charge tapes. So to begin with this lab, we had to figure out the charge of a piece of tape, first of all, and then we had to calculate the amount of charge that we needed to lift another piece of tape with that piece of tape that we found the charge of into the air. So for this lab, we're going to be using principles of both the force of gravity and using Coulomb's law to find how much charge we're actually going to need to resist the force of gravity. So just a bit of like a preview into later on in the lab, we end up figuring out that we need a charge of about 8.6019 times 10 to the negative 10th coulombs. So some things that we need to know before we go into this lab, first of all, is the equation for Coulomb's law, which is F is equal to K times Q1 then Q2 over R squared. And you need to make sure it's important that R is a vector here. And then you need to know that gravity is 9.8 meters per second squared. And then the K that is up in Coulomb's law is actually equal to 8.99 times 10 to the ninth. Then, of course, force of gravity is equal to mg. And then we need to define what really is the system and what is the surroundings in this lab. And we figure out that the system is the piece of tape, and then the surroundings is the other tape and the earth. So for this experiment, we observed that because the tapes have the same arch, they repel each other. But they also would be attracted to any other neutral or positively charged objects. So the tape and the pen that we used were attracted to each other because of these objects, with the tape being negative and then the pen being a positive charge. And then if the tape was instead negatively charged, it would be repelled to the pen. And then again, if the tape if the tape was neutral, then it'd still be attracted to charged objects. And you need to know that the net y component of the force would be 0 due to no momentum changes, with both tape A and the force of gravity would have forces affecting tape B. And here on the left is just the a free body diagram of tape B with force of due to the electric field going up and then force of gravity pulling it down. So from the actual lab, we had some initial values and some data. So we found that the tape length is equal to 2.2014 meters. Tape mass is 0.2032 grams. Then the separation between the two pieces of tape was 0.002 meters. Using the mass, we found that the gravitational force was 0.00217 newtons. And then the electrical force using the separation, which was R, and Coulomb's law, we found that the electric force is 0.0181 newtons, using charge being 8.6019 times 10 to the negative 10th coulombs. So here's my glow script, the code right here. So you can see it ends up outputting that charge needed, just the value that we found earlier. And you can see within the glow script right here, we are defining the two unit vectors for both tape A and tape B. And then you see your variables Q and G defined up above, as well as the mass. And then, of course, the constant K. And then you basically have Coulomb's law within GlowScript as your charge function, and then it just prints the charge needed. But yeah, that's all this GlowScript is doing, is just taking the values that we determined up above and putting them into Coulomb's law. All right, some comparison between the data and maybe some possible errors. So the bottle represented the tape charges as identical point charges, whereas they most likely were not identical and were not point charges. Then some other errors could have been the handling of the tape, us using our fingers and taking away charge due to the charge within our fingers, as well as losing charge to the surroundings, as well as the force of some of the air currents in the room. That wasn't accounted for, things such as air resistance and maybe the AC blowing, as well as assumptions about the weight of the tape. Lastly, what if and why? So what if the proton and electrons were changed? In our case, the observations would be the same, but rather than moving around a negative charge, the positive electrons would be the ones moving. And then why is it important to handle the tape as little as possible? It's important because the more you handle the tape, the less charge the tape will have, and then it will begin, and the less they're going to react and repel each other.